Now let's talk about the normal distributions. Okay, so for the discrete case, I said I'm going to talk. I already discussed the binomial distribution, right? Now for the continuous, we know that we have a uniform, for example. So if you look at this textbook, for the continuous case, right? We have a uniform distributions. Although I'm not going to really discuss in detail, I want you to know that this is what? This is like a uniform distribution. Of course, it's a continuous, as you can see. And then there's another probability function is called triangular distribution functions. As you can see, this is also continuous, right? But we're not going to talk about these two distributions. Our main focus is what? The normal distribution, right? Of course, as you can see, it's a continuous, right? Okay. Now, this is a normal probability density functions. We never call it a mass function, right? Because this is a continuous. If this is continuous, then we have to say density, right? It's not a mass. So this is a normal probability density function, as you can see, and this is a formula, right? I don't want to talk about this formula too much, but things that you should know about this functions is that what? There's a mean. The mu is a mean, and sigma is a standard deviation, right? And then also, interesting thing about this normal distribution is that 68.3, this is a number that you should memorize. 68 of the value of the normal random variable are within plus and minus one standard deviation of its mean, right? And about what? About 95. So 68, 95, right? About 95 of the value of the normal random variables are within plus and minus of 2 standard deviation. And then the third one is about 99. 99, that's the number you have to memorize. 99% of the value of the normal random variable are within what? Plus and minus of the 3 standard deviation of its mean. Okay, so 68, and what is the next number? 95, and the next number is 99. Okay, so I want you to memorize this number: 68, 95, and 99. Okay, so as you can see, right? Okay, now, let's just look at one example, right? So there's a company, right? This engineering group, this Greer's engineering group. So this company estimate that if their engine receive a proper parts and replacement and preventive maintenance, the mean lifetime flight hours achieved is normally what? That's the mean, right? About 36,500 hours, right? I'll say just 36,000 hours, right? And standard deviation is about 5,000 hours. Okay, and this company would like to know what percentage of its aircraft engine will be expected to last more than 40,000 hours. And they're assuming that what? They're assuming that their lifetime, right? The aircraft engine lifetime follow what? Normal distribution. So that should be the assumption, of course. Okay, so if you look at this normal distribution, right? And if you want to find, so basically they said X will exceed $40,000. I mean 40,000 hours, right? Okay, so let's just write this down, this example, right? Okay, so so this is the, okay. So the idea is that this engine lifetime, right? This company's engine lifetime is following the normal distributions. And the good thing is they're given the average, the mean, right? And then they also, the problem also gives us the standard deviations, right? So the mean is mu, is, this is like population mean, by the way, the mu. And then 36,500. And then the sigma, right? Standard deviation is 5,000. Okay. So what they want to find out is the probability, right? So they like the percentage. What percentage of its aircraft engine will expect to last more than 40,000 hours? So basically, it's more than 40,000 hours. So let's say the 40,000 hours is around this, right? So basically, they want to find the probability, this area. You know that it's in the normal distribution, right? The area under normal distribution is the probability, right? So basically, the company finds out this area, the probability that it's their, what is like a percentage? What is the probability that the engines, right? Lifetime it's greater than 40,000 hours. So what is it? Okay, so there are a couple of ways you can solve this problem. Okay, any volunteer? What is the first way? What is the first way? So basically the probability that this, let's say x is a random variable that represent the what? The engine's life expectancy, right? Is greater than or equal to 40,000, right? 40,000 hours. And we'd like to find this area. So anyone? Actually, there are 3 ways, but anyone? How can you find this? Anyone? Hello? I assume that you guys already took the stat course, right? So anyone, how can you find this one? What is the first way? What is the easiest way?
Using Excel.
Yes, that's like, yes, but that's a third one. What is like what did you do when you try to find this probability in your stat course?
Fortunately, I don't remember the formula.
Okay, so the first way is, so when you have like a normal distribution like this, right? The first way is what? You transform this into what? Standard what? Z distributions. And then once you look at the standard, and then so like the formula that you should use is, I think this is, we covered this in the chapter 2, right? And definitely this is going to be in your midterm. So this $4,000, I mean, not the dollars, 4,000 hours, you have to transfer into Z value, right? So let's say this is a Z normal distributions, standard distribution, right? Then it's probably, this Z is like, I don't know, I have to calculate this. But let's say, assume that this is like 1.2. Okay, of course in the Z, the middle is a 0, right? And then to calculate this, you have to look at what? Z table, right? So that's how you should probably find out this value, the probability, when you take the stat course, right? That's the first way. This is like the first way. And another way is, I don't want to talk about this, but you can use, if you took the calculus, you can integrate, right? And then the probability mass distribution for, I mean, this probability what? It's not the mass, it's density function, right? So we have these probability density functions, right? So fx, right? So we can, like, 40,000 and go to infinity, and then we can integrate. So this is like using the calculus. This is a hard way. And we don't want to use this, and that's why you use the number 1, right? And then third way is, of course, we can use the Excel spreadsheet, right? So now let's take a look at this number 3, right? And so any questions? Okay. So the number 3, it's the Excel spreadsheet, right? The functions that you can use in the Excel spreadsheet is what? It's called norm.dis, distribution functions. Okay. The first value of the interest. The first is the value of the interest corresponding to the probability you want to calculate, right? And the second is the mean, and the third is standard deviation, right? And fourth is a true and false, right? True for the what? If he wants to the cumulative distribution, and then false if he wants just probability density functions, right? Okay. So now let's just. So what is the functions that you have to use? Norm. So this is like Excel, right? And then you can use what? Norm and dist, right? Distributions. Norm dist. Okay. So if you look at this, okay. So norm dist, right? Norm dist. And then the first value is the value of our interest, right? And in this example, the value of our interest is 40,000 hours, right? That's our interest. So we put the 40,000, right? And then the second value is what? The second value is BS1, so which is a mean. And then standard deviations, right? And then either true or false, right? And the true for the cumulative, and false is for the what? Probability density function, PDF. So if he just wants to find, by the way, this is the probability, right? The y-axis is a probability. If you just want to find this probability, right? This probability, then you use the false, right? But you're not going to use. I mean, it's rare that you need to use the false. Typically, most of the cases we need to use this cumulative case, right? Because, for example, in this case, right? In this case, you want to find that. Okay, so you want to find the probability is x is greater than 40,000. Sorry. So this value, right? But however, these functions only give us the cumulative, meaning these functions always give us this value on to your left, cumulative. So this will returns the green area, the cumulative. So what we can do, find what, so this is equal to, because we need to find this what? We need to find this red, right? This is something we like to find. So this is the red, right? It's equal to what? You know that the area underneath this probability density function is 1, right? So probability is 1. So we know that this area is 1, right? Under this probability density functions. So the answer is what? 1 minus the probability is x is, oh, sorry, you know what? This is greater than 40,000. I made a mistake. So of course this is the red one is greater, not right? And then this is what? 1 minus p less than or equal to what? So basically this is wrong. This should be the greater or equal. Okay, this is what? P is less than or less than equal to what? 40,000. And you know that this is the green, right? The cumulative. this is a green area, right? And it's equal to 1 minus this functions, norm, distribution, and then 40,000 and mean and standard deviations, and then you have to use a true because it's cumulative, right? So now let's just use the Excel spreadsheet. So now, okay, so let's just use our Excel spreadsheet if that is a true. So first I'm going to calculate this P is probability that this X is less than 40,000. So a norm, right? Norm, equal norm dot distribution, right? Okay, now the value that we are interested in is 40,000, right? And then the next one is a mean. The mean is 365,000, right? Oops, not the 00, 365,000, okay? And then the standard deviation, what is the standard deviation? 5,000, right? And then, is it true? Yes, because we're interested in the cumulative. So it should be true. Okay, so that's the value for the green area, right? So we need to find out is 1 minus 0.758036, right? So that's the red area. So we can find easily, we can find what? The answer is equal 1 minus, this is A3, right? So it's A3, right? That's the answer, right? 0.24196. So about 24%, right? The probability is 0.24. So if you look at this value, is 0.24, right? 0.2420. So that's the answer. Okay, so any question? Okay, so I'm not really done with the normal distribution. I'm gonna next lecture I'm going to talk a little bit more about the normal distribution. There's one function that I like to discuss. It's called inverse functions. Okay, norm.inverse. And then I'm done with the chapter 4. So okay, so I'm done. So thank you.